Welcome to the Saving live stream, where today we have some beautiful reactions planned for you today. Maybe you have already seen, I did a video, uploaded a video earlier today. I recorded it yesterday. We will go into what I talked about in there a little bit and maybe answer some questions if you have any. Hopefully I did a good enough job. It was interesting. I might be able to share how I did it as well, because that was funny also. You want to talk about some stuff. Let's just go through so that people know what to expect and what they can ask.
There were a couple of questions on Discord that kind of sparked discussions about SPN and encryption, stuff like that. So that's definitely something that we want to just cover because it has been a topic for, well, our community, and I guess that most of you who will watch this video or live stream will probably have seen a discussion on Discord. So it's a great opportunity here to kind of just talk about things, answer questions, again, in a different manner. So we really want to make sure that people understand these fundamentals about SPN, because that's important. And it is complex, so it is hard. It's hard to explain and hard to understand. We get that, and that's why we think it's good kind of to reiterate on that.
Exactly. And every time we explain it, you can ask us new questions maybe, and we can learn to better articulate ourselves as well. Maybe update some blog posts, When I read, I think the Tor blog post was, our Tor blog post was shared, and I'm like, oh, this is old now. I think when we shared this, SPN was a concept and not actually in production. And SPN has been in production for almost 2 years now.
Testing or something.
Or in testing, And SPN has been in production for 2 years now. So, but again, I think I keep on saying this, we're not a media company. First off, we're not good at it as far as I can tell. I like this, but the reason I like this and the reason why we opted for this was that when we did the podcast in the past, it got out of hand. And we were like, oh, you're not supposed to say mms and uhs anymore. And I'm like, wait, what? I
so
understand.
This is authentic. This is easy, from a production sense.
Exactly.
Yeah.
And I like it.
If you watch Repo's video he uploaded yesterday, you definitely see what he means with we're not a video company. Because it's just very, very low tech, and I like it. It kind of shows more the process of thinking instead of just trying to purify information, condense it, and shoot it as fast as you can.
Yeah, that's
but
true.
Kind of and give enough context and fluff to follow, and.
But you actually walked in while I was recording, and
that's true.
I think you cannot pick up on that in the video.
You used that recording?
I used that recording.
Okay.
Yeah. No, I used that one. It was, I think, my third attempt, and you had some great input and what to use in regards to. Oh, no. Of course, I had to use the third one. You walked in on the second one. Whatever.
Okay.
Maybe I did not use the one that you think that you walked in, maybe on the one afterwards. Yeah, and I think I said this in the past as well. For me, it's easier to do 3 takes, 1 takes, than to, and don't do any editing.
Yeah.
Exactly. Yeah. I did some minor editing. There's a preamble now that I recorded today. That's the reason why it's the same shirt and stuff like that. And just as an explainer, so people sort of know what the rest of the video is about, because it was intended just as a quick response to someone on Discord. Yeah, the name I would have to look it up. But thank you. I think it was Ari. Yeah, Ari and Sodin who did most of the conversation and explanation, and I wanted to quickly sort of acknowledge what they did with a video explaining it in more detail. And if you're watching this, I'd love feedback on the other video as well. But of all of you who are here, please let us know what you like and don't like, and if I should do more such videos with crafts and stuff, and what chocolate bars to use next time. Exactly. Okay, but you wanted to do in response as well, so I will give you the stage to sort of like go less into how SPN works and how the stuff in there works. Please ask questions in the chat if you have any.
Yeah.
But you want to go into cryptography and about like people asking us or claiming that we're not state of the art in regards to cryptography because...
Well, the thing is with we have this thing called quantum computers, but we don't have them. We think about them, like we as a society, and there are a couple I don't know what to call them, like proof of concept quantum computers, but they can't do any meaningful, like for cryptography computation yet. So we're still really far away from anything serious. So a quantum computer is
Exactly. I wanted to ask.
A kind of a computer that works very different than we have, like our computers. Like our computers run on electrons and transistors, and they have bits. So they use base 2 for calculations, and there are certain problems in mathematics that are very difficult to solve. And that's what cryptography uses to design encryption algorithms, especially asymmetric encryption algorithms, to create kind of a system that works well in one way but very hard in another way, in order to have these security guarantees in there. And the thing is that quantum computers work on qubits, is what they call them. I think they have 3 states, and they are a lot faster for some mathematical problems, and I think slower for others. So they're just very different how they work. And that means that a quantum computer, the encryption algorithms, or especially kind of key exchange algorithms that we have, they depend on a mathematical problem that is difficult to solve. And some of these are easier to solve with the quantum computer. But that still means that the quantum computer has to be big and fast enough itself in order to actually be able to process that material and be able to kind of do that faster than a conventional computer or a supercomputer.
Let me quickly throw that in, because any cryptography, like how secure it is measured in euros or in time, because any cryptography can be broken
theoretically,
given enough resources.
Yeah.
The issue with quantum computers is that, as you said, like quantum computers are theoretical and to run them costs a lot now, but the thesis is that they will come down in price and increase in capabilities, maybe fast.
Yeah, similar to what we have with CPUs.
And that at that point, our current encryption methods will decrease in the amount of time and money you would have to spend on solving them rapidly, But basically, that's the thing. Like any cryptography can be broken given enough time and enough resources. But with quantum, that barrier would be lower. And so what people are looking for is different math that would keep that barrier high or higher for quantum. And actually, I think we talked about this in the past, but you said some of them, funnily enough, are then easy to break with regular CPUs. So there has been at least one that has been proven to be non-effective against current methods, which might be super cool against quantum stuff, but can easily be broken with CPUs, which of course, our current CPU technology, like with bits, this will not go away. So you need something that's hard for both.
Yeah. Yeah.
and be capable of asymmetric cryptography, because that's the important bit here. Symmetric is harder to break, I think.
Well, symmetric doesn't rely on a mathematical problem per se. It's a bit more like nuanced, but of a quantum computer will also be a bit faster breaking symmetric cryptography, but only twice as fast. So we can just double the key sizes. That's super easy, and we're good.
Especially because bandwidth is so high now, so doubling the key size. The reason why they're the size they are, because storage traditionally was not as high. Storage is
also
cheap.
Speed is a big thing with key sizes
That
too.
is
like
true.
CPU, like
It increases.
bit sizes in CPU and stuff like that.
Yeah.
So,
But typically, just for people, why are we talking about this? And it's like you can go and look this stuff up as well. But the initial, like to set up a connection, you have asymmetric encryption, and then you have things, and I think you probably have heard about this, session keys. This is a term regular people know, and a session key is in symmetric encryption because it is faster, it's less compute and stuff like that. Keys can be longer and stuff like that.
Yeah.
But of course, the issue is if you have that asymmetric encryption where the session key is exchanged
or generated from. Yeah.
if you can decrypt that, then you can decrypt the other messages as well.
Yeah.
And when people talk about post-quantum, they typically don't talk about the threat that's now, but they always are talking about the people that store that data and keep it for long times and then start looking at it and so on. Of course, like everyday people, and we will go into the technical details, and please ask us questions, but regular people probably have nothing to worry about here. It's like, yes, storage is cheap, but it's not so cheap that random internet traffic gets stored. Like if you're not under surveillance, you probably don't have to worry about this.
Yeah.
But
Yeah. So to continue there, so quantum computers will eventually, probably something be here in the future. Experts estimate quantum computers to become practical somewhere between 10 and 30 years. So there's still a lot of time until this comes, and we really have to decide between like what we're using for. So if you're trying to encrypt your backups, you probably should start using that sooner, because your backups will probably, you yourself will save them for 10 years. So they will be available then, or you have documents or like important stuff, then you should probably start worrying about this now. If it's just for like securing traffic, which you won't save because you got the product of the traffic, that's all you care about. And others, of course, could start saving that theoretically, but where's the incentive? Why should they?
exactly.
And also like how SPEN is set up, there's like so many layers of traffic, of encryption, and traffic is mingled. So you can't just save the traffic of one user. You just have to save it all, and that's a lot of stuff.
Yeah.
So
what is typically
it's
being saved?
very impractical.
That's true. What is typically being saved when people are concerned about like being surveilled or like?
So the typical thing, of course, is metadata, because
Metadata.
that's what actually is the basic stuff that you want kind of to find out who is who, what are you doing, who are they connected with, and that's kind of the base layer you have information. And then kind of if you're in a person of interest, then like a specific gathering really starts for your data.
But let me then ask you the funny question: why don't we encrypt the metadata? What is metadata? I think people have already know this, but like, let's quickly go through what is metadata? Why isn't it?
So
Why can't it
metadata
be
is
encrypted?
like in terms of like network stuff is like the IP address, stuff like that, but also like how much data flowed, traffic patterns can be metadata, but it's pretty more complex, and kind of like things about the connection, not the connection itself.
Exactly. So it's data about data.
Yeah, and that's what kind of the SPEN is made to reduce as far as and possible, and then kind of protect what's left over.
So like I showed in the video, we're breaking down packet sizes, we're changing them, we're padding them. So the data that the ISP could see about what sort of stuff is going through is even further reduced. And there might be a follow-up video about how the breaking up works and why it's so cool and stuff like that. But yeah, so metadata is data about data, and that cannot be encrypted necessarily because like it's an observing like entity that sees, and you can sort of like mask it and try to mask it, but there is basically nothing like in there to encrypt. Like how much, if you want to watch a video, the video has to arrive at your destination somehow, and you cannot hide the fact that you're downloading stuff with any amount of encryption. You can hide sort of like how much data you're like downloading, but that can only be more, never less, of course.
Yeah, you can change how the data looks like you're downloading.
That's what we are doing with SPN.
So SPN kind of tries as best possible to kind of normalize things, to break patterns in the traffic, mixes traffic, like spreads your traffic, mixes that traffic with traffic of other users.
Yeah.
So traffic patterns are reduced a lot. So it's harder to kind of get any grasp of kind of what and where is it flowing.
Yeah.
So SPN kind of optimizes on that heavily. So back to quantum encryption. The question is kind of why. Okay, it's coming in 10 to 30 years. It's urgent, definitely urgent for long-term storage. Although I don't see a lot of companies really jumping on that already. So I don't know what your cloud provider is, or your backup provider that you store your data with, or how you do your local backups. In 95% of cases, I don't think it's using quantum resistant, like post-quantum cryptography. Maybe check that out, but don't panic yet. It's still 10 to 30 years. So I'm not panicking. I sleep well.
And you're backing up data and saving data.
Yeah.
And again, like if you in 10 years, you would have to move the data over, decrypt it and re-encrypt it with post-quantum, or maybe
whenever that happens. So we don't know yet. And
exactly.
So that's kind of one thing, that the urgency isn't yet there, especially for network traffic. So we still have a lot of like way to go, and like of course things are slowly coming along, and I'm not sure if the NIST. So there's one competition. That's kind of how cryptography standards were like standardized over the last 34 years. That this American authority, NIST, creates a competition, and all the world people like teams enter that competition with their design, and then they start analyzing that, and like a lot of stuff was already broken. So I think there are like a couple of them that are promising. I'm not sure if the competition is even over. I would have to check. But still, we don't have kind of definite answer. Yes, this is the one. This is the algorithm that everyone's going to use because that's a safe one. We don't really have that yet. We're getting there. We have a couple promising things, but we're not quite there yet. And that means, of course, that needs to be defined, and then all the cryptography libraries have to be, so this argument has to be implemented in other languages, and that needs to be verified, and then libraries need to use that, and then the system needs to use that. So what we're waiting for is to something become practically usable. And SPN is built to be able to just incorporate that. And of course, we just won't switch over to only that, because we'll use it in combination with kind of the current stuff we have, which is definitely state of the art. That's what all the cool guys are using at the moment.
Military grade encryption.
No, post-military.
Oh, post-military grade. Oh, I'm sorry.
No, it's like Space Force grade military
Ooh,
encryption.
Space Force grade. Okay, well done.
So for example, I think Google with like the Chromium thing, they already have some testing in there where they're testing some stuff. So it's slowly coming along, but we're not there yet. And also there are downsides to that because currently all the options we have one of two things. They have either huge keys, so like 1 megabyte instead of 30 or 60 bytes.
And bytes and megabytes.
Yeah, so it's
there's
like
kilobytes in between.
It's huge.
Yeah.
So, or they're like really computationally intensive, so they need a lot of CPU, and like both aren't really that cool. So we're still kind of also need to figure out kind of how would that work with SPN with like huge key sizes or like all this computation, and how often would we do that? Because right now SPN kind of rekeys every once in a while, so we kind of reestablish keys kind of just in order to be super safe in case something leaks somewhere, which is kind of iterate the key and rekey. So that's called perfect forward security and perfect backward security. So in both directions, we kind of have cutoff points. So if in case something happens somehow, we kind of reestablish trust all the time. And make it impossible for an attacker at some point to kind of follow along the stream too long, which shouldn't happen in any case because the cryptography works, it's sound, it's state of the art. Our cryptography library is audited. Everything's found there. So, but that's kind of just that's state of the art, having these mechanisms in there, and we have them. So that's super sound, and we're waiting for a definite answer to what is the best post-quantum cryptography algorithm. And when that's there, we'll start working.
Yeah. Because again, as I said before, some of them have been proven very ineffective, and it's just sounded good and stuff like that. And we don't know also because we cannot test it until there is actual like some quantum compute available that's like actually capable of attempting to break encryption like this.
Yeah, there are a couple like proof of concept stuff, and ideally would love to have the algorithm in the Go standard library because then we know that's super tested and audited, optimized everything to a maximum degree, and you will see when that happens.
Exactly.
So, and there is no urgency at the moment. So I personally believe we won't make it in 10 years. It's probably going to take longer, especially now that all the money stopped flowing to quantum, is now flowing to AI. And AI definitely won't be faster at breaking cryptography or doing some stuff like that. So
no.
There's other stuff to worry about, like privacy.
Exactly, because AI is actually like going into a different direction in that regard. And it's doing like linear compute with like slower cores and more of them and stuff like that. So very different from the type of processor that's required. And of course now with the NPU stuff, all the resources, it's not just AI as like the models where the money goes, it goes there as well. But if you've seen the AI PC stuff from Microsoft with the NPUs, neural processing units, again, that's basically more akin to what a GPU can do than what a CPU can do. And it's from the type of math they're like designed to perform, away from the direction that quantum actually goes. So from more complex to sort of like more linear and parallel That's what the GPUs and NPUs are like designed to do.
Yeah. So if you're worried about privacy, probably you should be a lot more worried about how AI will be able to analyze your metadata, your traffic patterns, and all that, and not so much about post-quantum cryptography.
Which is what I did the video about, you know? This is the reason why I did the video, because I'm like, the explanations on Discord have been very cool. Again, Ari, thank you for all the work you put in there. And I think and hope that the resources we put out, we have been referencing the white paper quite a lot recently. Of course, white paper, even older than the Tor blog post. And that this has been written before SPN, I think, has even been in an experimental and some lab experiments have been done. But this was basically the document that guided the development, because like in there we already talked about traffic analysis and the principles and stuff you have to do, where you have like fixed packet sizes and you have like routes predefined so that the traffic is forced to mix. There has been a question, I think on YouTube as well, where people have been asking, no, on Discord it was, about Tor, and where like Tor has no fixed routes. So you can, like, if you're the only connection between two random nodes, that connection is yours and it can be followed more easily because of that and stuff like this. So Tor has other stuff. It's also great. Not bashing on Tor here, but we actually thought about this and looked at Tor, looked at what they did, picked out the stuff that's good with them, added stuff that's like developed in the 20 plus years after Tor has been envisioned.
40.
40?
Yeah.
Okay.
I think Tor is like really old.
Not 80s though. Okay, maybe, I think 1990s,
okay,
but whatever.
I'll have to check.
That's the reason why I said 20 plus years.
Okay, good.
I was like, could be 30, but 40 I think is too much.
Like Tor actually, and that's so funny, Tor was, the first version of Tor was built before VPNs.
Yeah.
And that's so crazy, because like Tor was built and VPNs didn't exist even yet. So
but of course not really with the bidirectional. Like .onion I think was an addition.
Yeah. That of course. But the basic idea was developed at the
Navy.
At the Navy, at the Naval Research facilities.
Yeah.
And they actually built the first version kind of Tor back then, before there were even VPNs.
Yeah, and VPNs have been built
really
again,
interesting
for security and for companies.
Yeah, for connecting two sides of a company together.
Exactly.
That's the use case.
That's the thing they wanted to keep private to company connection.
Yeah, confidential. It's a confidentiality tool.
Yeah.
Not
actually a privacy tool, exactly. Yeah. So bad name now, but of course, like those companies are sort of like taking that naming, which was
it's a private, not in the sense of privacy, but in the sense of
confidentiality,
private property.
Yeah, private property. Yeah, you're right. Yeah, right. Okay, and so like that's the reason why I did the video, why I wanted to display that, like, what does fixed packet sizes mean, and what does like the beaming mean, which I keep on talking about, like how does this sort of like look like and so on.
Yeah.
And so I hope I did a fairly good job in visualizing this and sort of like explaining why it's so hard to see from the outside where traffic is flowing, how traffic is flowing, and if you don't see that, then the metadata is very useless. And with Tor, of course, like the fact that there are no fixed routes is one of the factors, and with VPN, the big factor is people have been asking us, and that's partly the discussion which I read on our Discord, like about logging and so on. And so logging is basically the fear of metadata collection, either by the VPN company or in our case by us. And what I then expanded it on in the video, and what I wanted to sort of like maybe iterate here as well, if you have questions for the live chat, like you're concerned about your ISP, and people are saying, well, your VPN then is your new ISP, but that's only half true, because the VPN has an ISP, of course, as well. And that ISP sees the traffic pre-VPN tunnel and post-VPN tunnel. And what I said in the video is, well, if we're talking about metadata, you're concerned about bit size and so on. And computers are very good in knowing bits, you know?
Yeah,
We as humans, we look at 2 kilos of flour, for instance, we're like, yeah, that's both 2 kilos. But a computer knows how many grains of like flour are in each perfectly. And so it can spot the difference, and it can follow like the one bag coming in and then put into aluminum foil and then going out the other end, and it knows like how much this is the same. And with encryption, that is, yes, a remixing of all the grains of flour in the bag, but you're not putting any grains out or adding any to it. You're only adding the aluminum foil, which is the same on each bag of flour coming in and out. Yeah. So even if you don't know the order of the flour inside, it does not matter because you can follow the packets.
And that's kind of, especially kind of because we talked about AI, that's kind of exactly what AI is amazing at.
Yeah.
Finding these relations between encrypted traffic and the traffic outside of the VPN tunnel. And it's so super easy for a neural network to match these together and be like, okay, this is this server, and I have 100 connections to the internet, and I have 10 VPN connections. It's super easy to see which connection to the internet came over which VPN connection. It's super easy, and these are servers just in a data center. So the data center sees what happens, the ISP of the data center see what happens, and the next ISP probably too. Yeah. And that's kind of the internet. The internet isn't like public roads. The internet is an interconnection of private networks, and every one of these networks can just capture and analyze and do whatever they want. Yeah. And of course they won't break your encryption, but they can look at traffic patterns.
Yeah.
Some of them just sell NetFlow data.
Yeah.
You can buy that and like per terabyte. Like,
yeah. And you were
buy a little, and like that. Some companies do that just to do research, like to kind of have data sources for the kind of looking into things, like how do things work on the internet.
Yeah.
So that's just business. Yeah. You know, no issue.
And it's not just like research. I had actually the chance, and I mentioned this in a comment. I can go into more details in different regards of different attack vectors, but DRM software is created to recognize video streams in the data stream as well. I had the chance, I think it was last year, to talk about to the people who purchased MindGeek. And part of what they wanted to acquire was this technology. And if you don't know who MindGeek is, some people don't know, that's the other U, but not the tube, and the other hub, but not Git. You know? Very
well put.
That's the umbrella corporation owning all those entities and some other subsidiaries as well.
They pretty much own the whole.
Yeah, was super interesting conversation to talk with that I think he was one of 4 people who managed the fund that bought MindGeek. Really interesting. And again, like
so, what can they do with that technology?
They can recognize, because like that type of video is being pirated a lot as well. They can recognize their video in a data stream, and so what they are like. They have contracts with different ISPs to match against those fingerprints and stuff like that. So they can take down.
They will see that you're watching that video over your VPN.
Over your VPN.
Yeah, they will see that.
They can.
The data is there.
That.
It's metadata. Yeah. It is there. So, yeah, that's the world we live in. It is private networks, and all are looking at the streams. We have AI technology. It's gonna just improve all that metadata analysis, and that's why we need stuff like the VPN, the SPN, because VPNs
cannot do that.
Can't do that. And there are companies that start going that direction. I think MoveAd started like doing some stuff in that direction recently.
Exactly, fixed packet sizes.
So things are coming along, but still, most VPNs it is just a tinfoil wrapper.
Yeah.
It doesn't really do much.
Yeah. Especially like with that, the mixing is less because it's only one node, and then it's for marketing purposes. Again, like I mentioned in the video, for us, doubling the amount of nodes we would have would mean basically on that day halving the connection on each of the nodes. So the mixing is halved as well. So for us, it makes more sense to like upgrade servers, increase the bandwidth that's going through each server to increase the mixing, to increase the privacy. But of course, like people are now asking, oh, how many nodes do they now have and why isn't it growing? Well, because it makes sense to increase the capacity of the nodes first. And I can tell you, SPN is used a lot, and it's very cool to see, cool, but it's cool to see the bills getting higher because we have to pay for more bandwidth and stuff like that, because we know that people are using it and that we know that the traffic mixing works. And we rely on your feedback on speeds, and if people are saying, well, speeds are not great. And I think last live stream somebody from India said he does not understand why we're saying in Asia the SPN speeds are not so good.
That was cool, yeah.
It was super cool. If you're watching again, mate, thank you for that information. But we're always improving. We're always looking at what nodes are how much like used, and if one node is very like overloaded for a long time, we either would add another one there in the same region. We cannot control the traffic because each port master chooses it themselves. But sort of like if a second node is in a good location for similar sort of traffic, are we looking into like increasing the capacity of that server or stuff like that? Mike actually said something. I'm sorry if you wanted to say, but I wanted to say, hey Mike, thank you for being here. And you said our post VPNs are post for sure. Okay. Max out the nodes, it's the best strategy. Yeah, no, it is for privacy as well. But of course, like from a marketing perspective, stuff like, and we talked about this earlier, Mike, I don't know if you saw this, but post-quantum, of course, is a marketing term now. And people are looking for it, and it's hard to explain to people why it's actually
why it's not their priority right now.
Why it should not
other
be.
Things,
Exactly. And again, like, and then counter to what they think they want is less servers, more servers with less people on them because that would increase speeds. But then traffic analysis is easier, and so we're trying of balancing it.
And of course, there is a balance because of course less servers and less IPs means worse IP reputation, which means that gets more difficult to kind of keep a good reputation. And kind of we had our first provider now very softly threatening to kick us because of all these DMCA requests that got triggered over the last month because someone decided to do a lot of torrenting over ESPN.
Yeah.
And that's kind of a thing like, we're like, you can do it. We're not happy about it. So we would prefer people not to do that over the ESPN.
Torrenting, legal stuff, absolutely great.
Yeah, no. Linux ISOs, please. Torrent all the Linux ISOs you want. But don't make it harder for us, please.
Torrenting copyrighted stuff. That's true. Yeah. No, and we are like with stuff like this in a pinch. We know, and also keeping speeds up. It's not just what you said about reputation, keeping speeds up and stuff like that. It is work, and it's more work than just spinning up a new RAM only whatever VPN server somewhere and
call it a
woo. Exactly. It is more work than that, but we feel it's required and it's necessary. I just figured out that I might have killed our chat as well. If somebody was writing in the chat, no. Okay.
How can you kill the chat?
There is this banner every time when I open the chat, and I wanted to I used uBlock to get rid of it. I thought maybe I've killed the chat, but no, it's apparently only Discord currently who is chatting with us. So if you wrote something on YouTube and I did miss it, I'm sorry. Discord works. But yeah, no, we're not. We don't want people writing on YouTube. I just hate the banner because then I cannot see the latest comment. Okay, do you want to add something towards post-quantum encryption or to traffic analysis in general?
I think we covered a lot of great aspects about that. And we'll just have to see how the internet evolves.
Yeah.
How AI changes how internet ISPs do traffic analysis. Kind of how the privacy space in general changes. Because if we look at like governments all over the world, like pretty much all of them are like, we want more access, we want more data, we want to access people's phones without breaking encryption, stuff like that. And everyone is like, that won't work. But they're like,
we'll give it a try.
We'll give it a try. So, so traffic analysis is definitely something that I see increasing with all this like AI hype. And also not only traffic analysis, because that analysis, I think we can already do pretty well, but it's gonna get a lot more interesting because I think that the current large language models that we have will make it more accessible. So you won't be needing an engineer anymore. So you'll have just one huge box that collects all the metadata, and then you can just ask it to like kind of also plug in a database with kind of patterns of known content, and then you can ask the AI to kind of find references, so find kind of IP addresses or persons with multiple IP addresses that kind of fits a certain profile. So kind of I'm looking for people that did these things or a combination of these things on the internet, and then
it hallucinates 3 people, and we're all safe.
That'd be nice, but it probably would point them to kind of a good set of IP addresses and be like, so either, of course, the first thing will be, let's make more money, let's try to sell these people some product because we know they've done these things on the internet, and then the next thing will be, we want to like find these evil people, and we know that these evil people do these things on the internet, and whoever fits that bill, well, you're now evil. You're welcome.
And again, with privacy,
and you'll be treated as a criminal just because of like weird traffic patterns, and that's what we're seeing around the world starting. Not yet with encrypted internet traffic, but with kind of all the other information that's already available about you. And that's just how things are. And that's kind of why we need Portmaster at SPN in order for you to control the information that is out there about you. Of course, you have to do your part too. Portmaster is not kind of the all-in-one solution, not the pill you swallow and all it's good. You still have to do your own thing and stop actively sharing your information, for example.
We don't block you from posting pictures about where you live on Facebook. That's on you.
Exactly. That's on you. So, but we need these steps in order to continue in normal life, I think. And it's just gonna get worse. So,
especially because like with stuff like this, you're allowed to change your mind, and you're allowed to evolve as a person, and to like in 5 to 4 years, who knows what you're then like, what you believe, what you're interested in, and so forth. So what I like in regards to privacy is the saying that it's not just me not trusting you now with my information, but me not trusting you, like the entity that you will store this data with in the future with that information.
And what the entity will become.
and what it will become and where the data might leak changes. And stuff like this. It might not even be them. It might be somebody else who gets access, like malicious access to that data in the future and stuff like that. So yeah, and I think like policies are always great. Stuff like no log policies are good, but you need to be wary about more like have a broader perspective. In the video, I mentioned the potential of hacks, and you already said data center. It might be the if it's a virtual server, RAM only, whatever, it might be the bare metal that's underneath that's hacked, which of course the virtual stuff inside cannot know. Or if it's not the bare metal, then it might be the switch on the network rack that's hacked, or on the data center, the switch, or again, like the ISP, or in the switch on the ISP. Like it's so much stuff. It's like you need to have privacy. Everywhere. Exactly, you need to have privacy by design, and not just by policy. And again, like also with GDPR and telling like you have to have reasonable like reason for data to be collected. But any data like can be leaked, can be stolen, and it's good practice to have as little out there as possible. Yeah. Have you written right?
Mike said that privacy stays exciting because it's an ever-evolving journey and it's a constant education, and that's true because it's kind of a war and a cat and mouse game, and you just if you stop evolving, you start losing. So that it's super annoying because we'd love to spend our time differently, just ensure time at the lake, hike up a mountain, eat some sachatvata as we do in Austria. But it just requires us to be alert and to fight this this battle. That's just sadly how things are. Yeah. And if we want to continue living the life we want, we'll have to do that.
Mike said the big fear is where data ends up. So true. And then the other thing he said is he can attest that network switches can be hacked, and just ask the Board of Trade in Chicago. Well, they're more and more getting like being computers as well. Which has a good thing as well. I know that I think Western Digital, or was it Netgear, they're thinking of outsourcing some of the compute to network switches as well, and doing maybe like some stuff in there. Of course, like with encrypted data, that's hard to do. Who knows? But there are like small computers now, or a lot of them are. They're dumb switches as well, but typically if you run a data center, dumb switches is not what you're installing. You want maximum bandwidth to each of the hosts you're serving.
All the kind of management stuff and quality of service and
true.
Performance,
monitoring,
everything.
Yeah, which of course is some sort of metadata as well. Performance monitoring.
That's true.
Yeah. Well. Cool. Thank you for you brought up this topic.
It was there. I didn't bring it up. I just responded.
Maybe we'll put that link to this episode on the GitHub issue. Who knows? As an answer. But yeah, from our perspective, I think it's time to wrap up. If you have any questions, please write them into the chat so we can respond. Do we have other housekeeping?
I don't think so.
You don't think so? Maybe then let's tell people who have been on the beta channel and maybe have switched back, because one of the earlier betas has been causing issues. Those issues have all been fixed, and we have put up, I think, 3 new versions now, and there is one.
Yeah, so the current
not
version
for beta tomorrow. It's for staging tomorrow, isn't it?
Yeah. So there's one kind of the latest version. I think is 0.6.13. Runs very well already. Also, people who had previously had issues with blue screens are reporting having no blue screens anymore. That's awesome.
So we fixed that.
Yeah, very grateful for that to be fixed. And so there are like minor fixes still coming, so there's more info in the beta desktop Discord channel.
Yeah. Vladimir wrote in there that
it's just a small thing, nothing serious.
Yeah.
But yeah, we're continuing to improve that, and so we're continuing to finalizing and testing the new kernel extension to bring that to stable as soon as possible. And the next thing will be the new UI, which we talked about 2 weeks ago.
Absolutely.
Which will come then. So that's kind of the two things we're working on, and the cool internal stabilizing stuff.
And if you are just a little adventurous, because we feel like it's very stable now, please try the beta, especially on Windows, because
Definitely.
the text is on Windows.
Yeah.
Please switch to the beta channel if you're watching this. And if you see any issues, please report them. We need to know. I have not seen a lot of activity in the beta channel recently, which gives me confidence that all is well. But again, like that's the reason why I said like housekeeping, like we need this. We don't know how many people are in the beta channel because like, again, we don't track our users. We don't know how many are.
Yeah, we definitely have no crash reporting.
Exactly.
So if you have a crash or an issue and don't tell us, we'll never know.
Exactly.
Which is, of course, your decision to report or not.
Please do.
But please do.
Please do. This helps us a lot.
Even like if there's an issue already somewhere that describes what you're experiencing, please chime in. Just say, I'm experiencing this too. It helps us kind of get a feeling for like, okay, how widespread is this?
Yeah.
Like how many Windows versions, platforms does this affect? It helps us narrow down kind of where the issue could be.
Exactly. Yeah. Exactly. If it's on Windows 7, we don't care. But sorry.
Windows 7 is really old now.
Yeah.
If you want privacy and on Windows 7, find an alternative.
Linux. I'd opt for Linux, Fedora. Give it a try. Love it. And maybe Pop! OS Cosmic is coming out soon as well. Maybe that's more your cup of tea. But yeah, switch away. Great.
Yeah, there are Windows versions that kind of help you, or like tools to help you remove bloat, stuff like that. So yeah, if you're scared of Windows, I am too. You can help yourself.
Chris Titus actually has a cool tool where it can also create a Windows 11 ISO, and I think it's just a combination of tools that he did not build. But it's a sort of like cool collection of stuff, and Portmaster's in there as well, which I like as well. So I saw this as a big sort of like recommendation for what we do as well, and super cool. But yeah, maybe look into alternatives. Mike then said, beta release days is always nice. Big thanks for both of you for always improving. Yeah, thank you for
testing.
For testing, for like the encouragement, all the kind words which are sent our way. Thank you for everybody who's supporting us with like subscribing to Portmaster Plus or to Portmaster Pro. This is what helps us keep the lights on and what helps us put in the time to improve all of that stuff. Mike said, petrified of the modern distro of Windows. I can't even call it a distro. Just distributing behavior
Disturbing
behavior from them. Yeah, okay. No, true. I agree. But again, like there are alternatives. Take a look. Windows 10 is approaching end of life as well. So maybe it's time to switch. Never thought like 5 years ago that I would recommend it to people, like looking at Linux, but here I am.
Yeah, Windows has gotten really weird.
Yeah, and I'm even like people who know this, but I'm even gaming on Linux. Like I haven't started my Windows boot drive in like, I think 1.5 years, maybe 2 years now.
Wow.
Yeah,
that's good.
Yeah, Proton has come a long way. Like that's a Steam twist on Wine, which is Wine is not an emulator, but it feels like one.
It kind of it does funky things to allow Windows stuff to run Linux.
It's a translation layer.
Don't ask questions, just take it for magic.
Exactly. And I think it's only one switch in Steam you have to do to make all your non-Linux games work on
Well, all.
Linux. Most of them.
Many.
Yeah. Almost all of them. Maybe as a recommendation if you're building a new PC and if you're interested in that sort of stuff, go for an AMD GPU. NVIDIA is not as good with supporting open source stuff at this point. Cool. Well then.
I think that was a great episode.
I think we covered a lot of stuff. Feedback again, always welcome if you're watching this afterwards. I saw that the last live stream had over 100 views after we recorded as well. So if you're one of those people, leave a comment below. If you have questions you want us to answer in 2 weeks from now. Also, if you have not seen my video on SPN, VPN, and the logging stuff, watch that video and tell us or tell me what to do different next time, what things you liked, what you didn't like. Feedback helps us improve. Final words?
No.
Great. And have a very nice end of the week. See you in 2 weeks.
Bye.
Bye.